Good evening, and welcome to my TED Talk. Today, I will be explaining all of my code in Cooper Cards, starting with main.lua. Connor, I think that you are also being recorded in this, so you speaking will be audible, I think.
Hey.
Also, I will send this through GitHub as a separate thing from main, so that you will be able to check it at any point. Okay, starting with the top, local scene manager equals require, and then the quotes scene manager tells main.lua to use scene manager.lua here. That is just so that it actually knows to go to this file and read its code. This is the exact same thing, except it tells it to use a specific asset for the font, which is here, which is awesome.ttf. You have to put it in quotes, and if it's in a folder, you have to put a slash. But you only use the slash if it's an asset. If it is an actual text file that is in a folder, then you have to use a dot instead of a slash. It is cap specific, by the way. This 12 here simply sets the font size. This portion here makes a table that shows all of the base resolutions and the default volumes for master volume and music volume. This here, resolutions, shows the different possible resolutions in a table. The reason why this here in settings also has brackets around it is so that it knows that it can be changed to these numbers and resolutions. This current res 1 just means that this uses these numbers, the first ones. If this said current res 2, then these numbers would be these numbers. This here sets all of the baseline info for the fade in and next scene info, which will be used later. All of this is global, by the way, except for this, because it doesn't have local in front of it. Since this is at the top and it has local in front of it, then throughout the whole file, and only throughout the entire main.lua file, scene manager equals the scene manager file. But if I were to get rid of this local, then in all the files, it would mean that scene manager equals require scene manager, which is the file. The reason why we use local in main.lua is because there are different files in which scene manager might not equal the actual scene manager, and or scene manager isn't used regardless. And if we were to make this global, it might cause an infinite loop, which I will explain later. Here we call the screen size and screen height to be, or the screen width and screen height to be 0, 0. And then we say the base width and base height is 1280, 720. The reason why we do that is so that we can use these instead of the numbers to scale later. The default settings are 1280, 720, which is established via base width, base height.
Okay.
This starts the window at the chosen resolution, which at the moment, the default moment, is resolution 1. That's grabbed from the resolutions table. This just sets the global font. Since it's all in love.load, it loads it, and then it sets the global font for all the files to font, which is established here as awesome.ttf. And then this says make the scene manager switch the scene to intro movie. Intro movie is the scenes.intro movie file. And the reason why it is scenes.intro movie is because it is in the scenes folder right here. No, it isn't. Yes, it is. Sorry. Scenes folder, which is right here, and it is a dot because it is a text file that is Lua and readable rather than an asset. Here is the scaling for the global scaling. So this works in all the files, which is why we don't need to repeat it in every file. For where the mouse is based on the different resolutions. This basically just, when you change the resolution, it also changes all of the math for every file so that your mouse still works on all the buttons and stuff. This tells main.lua to update scene manager because scene manager is practically the whole functionality for all of the everything. And it is in main.lua because main is, well, the main function, so it will continuously do this no matter what. This here is the code for the fade out animation. Basically just says that if a button tells the fade state that it is now fade out, then it will change the color, which is, or change, not the color, the brightness. Change the brightness via fade alpha, alpha being the brightness, to be less than 1. Then it switches the scene to the next scene while the screen is black, so that it doesn't flash to the next scene and then go black. And then it switches the fade state to fade in, which runs this function here, which basically just does the exact opposite. It says that if the brightness is lower than 1, then set it back to 1, and then get rid of the fade state, ending the function. Here is the scaling for all of the graphics globally. So we write it here in main once so that we don't have to write it in every file ever. This draws the scene manager function so that scene manager can actually draw other files. This draws the fade animation so that it actually appears on screen. And this is pretty important. This basically, whenever you change the resolution, this little line right here redraws everything to a new size. It's super simple. It's really nice that Love actually just has a specific freaking function for this reason. But it has to have a push function paired with it, or else it will break the entire code and it shows this humongous error, which is super confusing and scary, but it literally, all it is just that you don't have a push function. Here it just tells scene manager that it's allowed to register other files key presses. This scales the button hitboxes instead of just the button drawing, so that when you hover over a button that's had its size changed, then it actually registers that you're hovering over it instead of just keeping it the scale of pixels that it originally was. This lets Scene Manager know that it's allowed to register mouse pressing. And then this is literally the exact same thing, but for mouse releases. Now on to Scene Manager. So, since Scene Manager is its own special thing, it calls itself a table locally. So, if we were to get rid of this local, then all of the files would think that Scene Manager is a table instead of a file. So in the scene manager file, we call itself a table so that it doesn't think that it is a file. Then we set scene manager current to nil. We set the previous scene to nil and next scene to nil. This basically just makes sure that everything is clean before we start messing with it. This line of code is just a simple error check. It basically just, if the scene that it's trying to switch to is not registered as a table within itself, then it will show this error so that it doesn't like fake working, because it will do that. It will act like it's working, but it's not, and then things will start breaking. This is basically just, if it has a leave function, then make the code register that the file it's switching to has a leave function and let it be allowed to run. This is the same thing, but for the enter. This right here means that the current scene is seen. Scene's value will change in other files to the actual scene that it actually is. This updates everything in the file that it's switching to and tells that file that it's also allowed to update itself. Same thing, but for drawing. Then same thing for key press, mouse released. Then down here, at the bottom of any of these files that are running themselves, it needs to return to itself so that anytime that it's called upon in another file, it doesn't start reading here, it starts reading from the top again. This is a very simple little file. It's basically just, what's the title, what's the base resolutions? This is the first class. It is a shader class, so it is different from any button things, but it is still an object class. So you must call itself a table within itself and not globally, and then you index it. The reason that you index it is just so that Lua is able to register raindrop : update instead of having to type raindrop.update raindrop dt every time, and this gets its own little color, which is the green, and you can call it a function. Otherwise, this whole line would be yellow, and it would be super difficult to read. It's just a lot easier to index things so that they have this green tint and they can be functions. Then, basically, in every class file, you are writing the blueprint for something. So the first time that you use it within the class file, you write raindrop function new, and then you write all of the things that it can be within it, and that sets a blueprint for other times that you use raindrop new, so that whenever you use it that time, you'll instead put this information rather than putting the variables for that information. I'll explain what this little spot is in the other object classes when we get there, but that will be towards the end of the video. This is just some easy math to randomly place raindrops at the top above the visible screen line so that they fall at random times and they fall like through the screen. And then this right here just tells it to keep doing this function over and over and over when it's called upon. This here just updates all of the drops so that they actually fall. Otherwise, they would just exist and then not do anything. And then this actually draws them on screen. So it draws raindrop image for each raindrop, which is established up here as asset/raindrop.png, which is right here, right here. So it's, again, assets/raindrop.png because it is not a text file. So it's a slash instead of a period. This, again, is super important. It is so that whenever raindrop is called upon in a different file, it doesn't start reading here, it starts reading up here. Now, this is a scene file. So at the top of it, you make sure that it knows what all of the stuff that you're using is. You say that within the entire file, but not out of the file, button variable is classes.button, which is this file here. And scene manager variable is scene manager, which is right down here. This establishes that the variable title within the entire file is a table. This establishes that buttons within the entire file is a table. This is just all of the assets and resetting them, and then these two right here are like setting the baseline, cleaning the slate for the rotation text every time that this is loaded, so that it doesn't save any information if you were to go back to this and then start the animation at a different position. This function loads the instant that the title file is entered into, quote unquote, basically just meaning like when it is called upon, then this function runs immediately. This says that if title music is not playing, then title music is what the title music is, the file that it is, then set it to loop, then play. Here, we create the buttons for the title screen with their positions, sizes, colors, and functions when clicked. Since it's a table, all the buttons inside will be referred to in one go or individually if needed via buttons and then brackets x position in table. If buttons was established as a local variable within the enter function instead of up here, then it would not be able to be used in the rest of the file, which is why we make it a local at the top of the file, then declare it a table twice. Basically, if we put local here instead of local here, then buttons would only be an established variable that equals something within this function here. We do this again in the function that occurs within this button. So I should explain this first, actually. So here we're creating a new button using the blueprint from button.lua, which I explained earlier. So this is the blueprint that we put using button.lua or button new the first time. Each time that you put something and then a comma within brackets in a button new function in a different file, you put these in this order and it reads them as that. So if we go back to title.lua, we can see that this first thing, here is the open bracket, and then we do the text is play, then comma, just like here. We wrote the text, then a comma, and then we do the x value and the y value, which are the baits width halved minus 100. So it's 100 pixels away from the middle of the screen. And the reason why we do that is because the width of this button is 200, meaning since it draws always, every time it draws anything, it draws from the top left corner, it will draw 100 pixels away from the half, setting it right in the middle of the screen. here in this function for the button, we call the intro locally within only this function, not within out of this file, but only within this function since local is here. Since local is in the function. Intro equals scenes.exploration.intro, which is right here within scenes and exploration. You use periods again because it is a text file and not an ACID. If we were to call intro outside of this function, then it would probably create an infinite loop since intro.lua requires scene manager, which requires title, which requires intro. And it would just keep feeding through that over and over again, and the code would never end. So Lua protects from that, and it crashes itself before it even tries. That's why you have to call scene switches, specifically like file switches, inside of functions rather than inside of files. This makes sure that the previous scene now equals title, and that the next scene equals intro. And that is just for the fade animation mainly, and also for back buttons. So since the previous scene is now title, if there were a back button in this play, which there is, or not in the, sorry, in intro, in the scene intro, if there were a back button, which there is, it would return back to title, and it knows that because previous scene now is saved as title. The next scene equals intro is only there for the fade out animation so that it doesn't immediately switch to intro. It does the animation and then switches the intro. Then these are all of the buttons that exist, and they're all established in a table shown by these brackets, which is also called buttons, so that we can refer to buttons once and it means all of this, rather than just having to refer to each button individually every time. In title update, which is basically the function that lets title update itself rather than having to go through main or scene, or having main.lua update title every single time that it's loading in a giant if statement. It updates all of the velocity for the rotation text just so that it actually moves around and fluctuates in speed. And then here, this function updates all the buttons in the buttons table, which checks if they are being hovered over or clicked. So basically, it updates every single button in the buttons table, which is why we established buttons, all of this, as the variable buttons on its own so that we could refer to the entire thing rather than having to refer to each individually. So now, only with 3 lines of code, we did what we would probably have had to do in like another 200. Then iPairs tells this function to scroll through the buttons table over and over and over and over again. It basically just checks every single spot in the table. And then B and buttons are equal. And we didn't have to say B equals buttons because they're called in the same line the same thing. So it's just something that Lua does, which is super duper convenient, super duper nice, because then you can just shorten stuff. For this one, it's the same thing as update. It tells title that it's allowed to draw itself, and then it draws the background at 0, 0 so that it fills the entire screen because it draws from the top left corner. Then it draws the text for the title screen, which is the bagel Cooper cards, and it draws Cooper here, and then it draws all the buttons on top of it. And the order does matter, because if we were to put this little block up here, then it would be behind the background and you wouldn't be able to use the buttons or see them. And again, this scrolls through the table over and over again and draws each button from the table based on its position. And that is done with eye pairs. This is the exact same thing, but for mouse pressed, and this is... Excuse me. This is what I was mentioning earlier. Um, title has to be, the return title has to be here, so that when title is called upon outside of this file, it doesn't read here, it reads up here. And that's super duper important. You can't forget it at the end of anything that is called upon multiple times in other files. Now for settings, it's kind of getting pretty understandable at this point now that we've gone through all the different types of files. So I'm only going to explain most of the new stuff now. So right here, you'll notice that we're doing something a little different and that we're actually calling specific buttons throughout the whole file, which we normally wouldn't do, but res button, master slider, and music slider are unique. They have different things that other buttons don't. So we have to call them specific things so that we can reference them specifically. Here is the same thing that was in title. It's just plays the music. Then here we write the resolution button. So this is the button in config that changes the resolution. We leave the text blank, but we tell it that the text actually exists by putting two quotations with nothing inside of them. The reason we leave the text blank is because in the function, which it changes the resolution right here, this is the resolution changing function, which is, it basically just scrolls through the resolutions table in main and then adds 1 to it so that it goes to the next line in the table, and then it sets the resolution to that new area in the table. Then that's what the set mode does. It sets the resolution to the values in the table. Resolution 1, resolution 2. Then res button.text, you set the text to X, which is established down here outside of the button, because if you were to put it in here, then it would glitch out because there's supposed to be a table for the button. But you set it here so that the text is now the current resolution. So whenever you load the settings scene, the button for resolution says whatever the current resolution is on it. So default, it would read 1280 times 720, even though we left it blank here because this function changes this. And this function makes it established that it can change. Here is the same thing as in title Lua. We make buttons and we establish the buttons as a table. But right here, we put res button in the table so that we can still refer to it with all of the rest of the buttons that aren't unique. In the back button, it just goes to the previous scene. And then it sets the previous scene as settings right after it does that. So that if there were a back button in the new thing, then you could just click that and it would go back to settings instead. Which there wouldn't be for settings, but just in case we added one, whatever, you know. Here in sliders, this is a different table from the buttons because it uses a different class. It establishes some new sliders, and the function is based on v, which is the value of the slider. Basically, it takes the position and then it establishes it gives it a number based on its position from 0 to 100, which is, it doesn't have to be 0 to 100, but it's set to 0 100 in the sliders function. In the sliders file, not function. In the sliders file. For here, we are literally doing the exact same thing that we have been doing for buttons, except we're doing it for sliders now too. And we have to separate them because they use different systems. Otherwise, Lua would be like, oh, wait, what the fuck? And then we draw all the stuff. We draw a rectangle under the sliders. And then we draw the percentages that the sliders change to the right of them, which just uses some simple math to make the equate the position to a percentage. And then this does it exactly the same, but for music volume. And then this, it just draws them, and then mouse press, and then S, and then again the return. There's nothing I need to explain that's different in save load, but there is a lot different in intro.movie. So, what this is doing is, if the video is not already loaded, then it loads it, then it calls it, this file, which is right here, and then it plays it, which is right here. The reason why we check if it's looping and then set the looping to false is because different versions of Love 2D have different default values for looping. So we make sure that if the default value is yes, then now it is false. Or if the default value is true, then now it is false. And then we play it. Then this little block right here fades into the movie real quick, just to make it look a little nicer. This checks if the video is still playing and if it has finished, then switches to the title screen if it's finished. Local OK is used to catch errors. Basically, if it isn't playing, or if something else is going wrong, or if it failed to load, then none of this will load at all, and it will just crash. Otherwise, it would try to load it and then probably do some dumb thing that harmed your computer a little bit. Here it just sets the value of the movie so that it's stretched to the entire screen width. You probably could make it play with its original like width and height, but if you did that, then you would have to draw it at a specific position, and I don't think that Lua likes it when you do that with videos. At least I couldn't get it to work. This is just part 2 of that. And then here, it stops the video when leaving the scene, and then it resets to the beginning here, in case we need to run the movie again, which we shouldn't, but maybe we will. Now, in path choice, this is where things get pretty dang interesting. So, left path, mid path, and right path are all buttons that, like in Settings Lua, are unique. They have unique things about them, so they need to be declared outside of the table, then added to the table later. We also now have a separate table for pause buttons. Here, we create 1,000 raindrops, and then we run them in raindrop.lua so that they're randomly placed throughout the screen. Here we stop the music. Then here, so the reason why left path, mid path, and right path are unique buttons is because they have a different shape. They aren't rectangular, and the default value for a button is rectangular. But we tell it that it is poly, for short for polygram, and then we establish each individual point of that polygram. So first top left, then bottom right, then top right. And it will put the points on the screen and then draw lines between them and then fill the area between those lines with the button. And we do that for each one, and then we put them back into the table for buttons. We have to do all of the unique button stuff before we do the table, otherwise it won't know what the hell left path, mid path, or right path is. And then normal buttons we just put into buttons as normal without any naming. Now we have pause buttons. The reason why pause buttons are separate is because there is now a game paused state, which is set default to false. Here we are now drawing game and script separately from the normal draw function because it just is a lot easier that way when we have a pause thing and a huge if table. And similarly here we have the script drawing system. So basically there's a table with a different choice of scripts, and then here it checks what the value of script count, which is normally like default value at the top of the file, set to 0, and then based on that it prints something different. So if the script count is 0, then it prints explore the woods ... left, comma, middle, comma, or right path. And then if the script is 1, then it prints script text 1. So it goes to this table and it checks which one is in the first slot, and the slots are marked by commas. And then if script count is 2, then it prints script text 2, script count 3, script text 3, and so on. And then this is the area that it prints it at. We'll probably change that system later because it is kind of like here we do the updating text, and right here it checks if the game is paused, and if it isn't paused, then it updates the rain, and then it updates all the buttons. And then here it says that if each button is hovered, then it changes the script count. So if left path button is being hovered, the script count equals 1. Then it goes back here and it says script count equals 1, so print script text 1, which is left path ... And if none of these are being hovered, then script count equals 0. Then, if the game is paused, then this stuff doesn't happen anymore. It doesn't update anything in the game anymore, and instead it updates the pause buttons, which will make more sense after I explain this. So when you're drawing the thing, it tells itself to draw the draw game function, then the draw script function, which are here. It just basically says run these functions. Then it checks if the game is paused, and if the game is paused, then it draws all of the pause buttons and the pause background on top of the game. Now, if all of this were still updating, then even though the game is paused and there's a paused menu overlaid on top of it, you would still be able to click all of the buttons, even if they're covered up. And that would not be good, obviously. So instead it stops updating everything in the game and it updates the pause buttons instead. Here, it basically is the exact same thing. It says that if the game isn't paused, then buttons can be clicked. If the game is paused, then pause buttons can be clicked, and they can't be clicked at the same time. And then this here is the code for the escape key. Basically, if the game is not paused and you click the escape key, then the game is paused. If the game is paused, then the game is no longer paused when you click escape. And then this returns to the top. Okay, now in intro, it's pretty much the exact same thing as path choice, except for the script. So here, we establish the entire screen as a button that is invisible. It doesn't have any text. It's put at 0, 0, and the size of it is the entire screen, and it doesn't have any color because we don't have the numbers here. Whenever you click the screen, it adds 1 to the value of the local script count. So script count is established locally within this file as 0, and then when you click, it does script count equals script count plus 1. So if script count equals 0, then script count is now 0 plus 1, which is 1. If script count equals 1, then script count is now 1 plus 1, which is 2. This prints the script count that is currently, like the current script count value in the console, but since I'm on Mac, I don't have access to the console, unfortunately. Then we establish all the pause buttons, and then we do all the things that we have in the past. Here, the script is different now. The script text is an actual script, and instead of being based on button hovers, it is now based on how many times you've clicked the screen. So if you've never clicked the screen, it says click to start. If you click the screen once, then it puts script text 1, which is, it's been a long night at Cooper's house already, so when he rushed out of the house to chase after that scream in the woods, you can only imagine how tired he was. And so on and so on and so on. Here, there is a difference in the functions. So it's love.graphics.print at first, which is just the normal one that we're used to using. Then, if you do love.graphics.printf, then instead it has text wrapping, which is established through another comma and then a value of pixels. It basically just makes a point where if you pass this many pixels, then it starts another line down. Here, if the script count is 5, so if you've clicked the screen 5 times, then the scene changes to path choice. And then all of this is the normal stuff that I've already been over. So this is the stuff for the sliders. Here is, as I've explained before, the blueprint for the sliders. But the difference between the sliders is that we have a lot of more math going on. It first calculates the new value of the mouse position based on its relative, like, to the length of the slider itself. Then it calculates the position of the knob that it is drawing to follow where you left it, and then hold where it is when it's released. Then it checks if you click on the slider, and then it checks if you've let go. Here, we have a little something different from the normal blueprint kind of thing. So we still do have the blueprint, but we also have this, which basically it lets the code know when it's in a weirdly shaped button. So it actually uses ray tracing a little bit. It shoots out some rays, and then it says from your mouse, and then it says how many times and how long does it take for that ray to hit the border of the buttons, and then if your mouse is inside hitting all of the borders within a certain time, then it knows that your mouse is inside of the weirdly shaped button, so it highlights the button and says that it's hovered. And that's all that that really does. Here, right here, is basically just like if it's established as a polygon instead of a rectangle, then you're able to use points instead of all of this mumbo. And that's basically it. And I will now show you all of the code working so far. So here's the intro movie, and then here's the game. So let's go to options first, and let's turn it down, because it's freaking loud as hell. And then we can change the resolution. And you can see the text of the resolution is changing. And then we can go back. And that's the fade in animation. And then here's the little rotation animation. Then, if we click save game, then we click back, it takes us back to the title, right? But if we click play, and now we're in the intro scene, and we click escape, and then we click options, and then we click back, then it sends us back here instead of the title. We can do the same thing if we go to save game and then we go back. And then we can go back to the game, and we can click on the screen. It's been a long night at Cooper's house already, so when he rushed out of the house to chase after that scream in the woods, you can only imagine how tired he was. But what I really didn't expect was a freaking evil witch to jump out and split Cooper into a bunch of playing cards. Blorkenstolma the evil witch. Now you'll have to search this cursed forest for your missing card pieces. And if you don't find them all before the next full moon, your friend Cooper will be stuck as a deck of cards. Forever! You. No! And then now this will be the 5th click, so it will change the scene. And you can see that the rain is falling here. It's being drawn up here and then falling into view. You can also see that it is not falling over the border and over the text or the text background. And that is because we drew the rain before we drew all of this stuff. So now we're in the path choice, and we can see that these buttons are in fact weirdly shaped. So they are not rectangles like the normal buttons are. So when you go into them, it shoots rays and makes sure that it is hitting all of these borders, which it does end like right there. And based on the time that it is hitting those borders and how many borders that it's hitting, it knows that your mouse is inside of it. So when I'm off of the buttons, when I'm off of these 3 buttons, here it says explore the woods left, middle, or right. But when I hover onto this one, it sets the script count to 1, and then it goes into the table and it says, okay, instead print left path ... or script count equals 2, so print middle path ... or script count equals 3, so print right path ... And we can still pause by clicking escape, and then we can go to options, and then we can go back, and then we're back. And then now we can go to main menu, and we can quit if we want, but I do want to show that there are still some issues. So when we click play again, it already knows that the script count for intro is 5. It doesn't reset it to 0. So it instantly loads into this. And the pause menu is still, like, the game paused for this scene only was already set to true. It wasn't set back to false. So those are still some issues that we need to fix. But that's pretty much it. Okay.